In 2017, sequence models dominated the field of AI. These systems processed human language the way a machine reads a ticker tape, grinding through data one token at a time, forming a continuous, linear chain of information. This was the recurrent neural network. It maintained a hidden state, a single box updated with every new word. But as new words compress what came before, the beginning is diluted, fading to gray. Researchers called this systematic amnesia the vanishing gradient problem. For years, this bottleneck was accepted as a natural constraint. If you wanted to process a sequence, you had to pay the price of sequential processing. AI was trapped under a ceiling. Machines could not achieve deep comprehension because their underlying structural physics forced them to forget. In 2015, a new idea called attention was introduced as a patch. It was an add-on that allowed RNNs to occasionally look back at earlier words. It was a correction bolted onto a flawed design. In June 2017, 8 researchers at Google published a paper that shattered that design entirely. The title was a provocation: "Attention is all you need." The hypothesis? Throw out the recurrence, discard the left-to-right hidden state, make the patch the entire architecture. Paradigm shifts don't happen by optimizing a bottleneck. They happen by recognizing the constraint and destroying it entirely. The replacement was the transformer. Instead of reading word by word, it processes the entire input sequence simultaneously. This is self-attention. Every word queries every other word simultaneously, forming a dense web capturing total context in one flash. Multi-head attention splits this into 8 parallel layers, noticing different relationships. Positional encoding then stamps each word with its location coordinates. The transformer changed language from a linear timeline into a topographical map of relationships, readable in an instant. While the theory was elegant, the true impact of the transformer was revealed by the hardware it ran on, the GPU. GPUs perform thousands of mathematical operations in parallel, but RNNs forced these massive processors to wait for sequential steps, leaving most hardware idle. The transformer removed that dependency. Every computation across the sequence runs simultaneously. The entire GPU illuminates. Training accelerated from weeks to days. The industry shifted with violent speed. In October 2018, Google released BERT. That same month, OpenAI released GPT. These models set new records on 11 different language benchmarks simultaneously. The performance gap was so large that researchers who had spent years on recurrent networks began rewriting their systems within months. The shift was absolute. The transformer turned a software bottleneck into a hardware advantage, forcing the total abandonment of the sequential models that had defined the field. Previous AI architectures hit walls where adding more data stopped paying off. The transformer did not. In 2020, OpenAI released GPT-3. It used an unprecedented 175 billion parameters to process hundreds of billions of words. Scale alone unlocked emergent capabilities. Without being explicitly trained for them, the model could write code, summarize legal text, and answer complex questions. The architecture then spread beyond language. The same mechanism used for translation was applied to computer vision and protein structure prediction with AlphaFold. The 2017 decision to abandon sequential processing removed the physical ceiling on machine capability. This mechanism, attention over sequences, now serves as the operational substrate for almost every major breakthrough in modern AI.